Hello, I'm Sue Nelson, and this is the Planet Earth podcast. I've just arrived at Britain's second largest city, and my train has pulled into the heart of one of Europe's largest retail developments. Nearby is Europe's largest public library. There are more than 2,000 kilometres of roads here, and there are more than 430 schools and 3 universities. And I'm off to one of them to find out all about Birmingham's urban heat. Plus, we'll be going back in time with hands-on painting by ancient artists.
This part of the cave, maybe 41,000 years ago, was decorated by people putting their hands against the cave wall and then blowing or spitting pigment to create these negative hand images.
And please don't try that at home. From Birmingham's New Street Station to the University of Birmingham's meteorological site, and a fenced-off piece of grass, about 20 or so metres square, full of equipment, some spinning or most of them on metal tripods or poles. And I'm with Dr. Catherine Muller from Birmingham's Urban Climate Laboratory because you're working on a project called High Temp, and it's all about urban heat. Well, we're definitely in an urban area with a city of Birmingham population, more than 1 million, but not so much about the heat because it's been pretty cool and it's raining. So how do you explain urban heat on a cool, wet day?
Urban heat is basically cities and towns experience elevated temperatures compared to rural areas, the surrounding countryside. This is caused by artificial surfaces such as roads, buildings, which absorb the solar radiation during the day. They store that heat up and slowly release it during the evening. So over the night you tend to get these urban heat islands occurring.
So an urban heat island then is just basically a part of a city that's a bit warmer than another?
Essentially, yes. I mean, you tend to get the centre of the city centres that are a lot warmer. So when you actually plot the data up, it looks a lot like an actual island, as you would imagine it, with high temperatures in the centre, getting lower as you go towards the surrounding countryside.
What sort of temperature difference, what sort of heat are we talking about here, say between the centre of a city like Birmingham here and maybe 10 miles out in the countryside in the Midlands?
During heatwave events, you can get them up to 5, 6, 7 degrees warmer. For a city like London, you could be looking at maybe 10 degrees warmer. It does vary depending on the sort of weather event that you're experiencing.
And with something like a heat wave, then if the temperatures are higher in a city, that must have health effects in the
definitely.
UK.
I mean, that's one of the aims of the project. One of our partners is the Birmingham City Council, and they're particularly interested in where the high risk areas are within Birmingham. For example, if you cast your mind back to the 2003 heat wave, it does seem like a long time ago today, we had in the UK alone about 2,000 excess deaths. Most of those were occurring within the city centre, and that was always attributed to the increase in temperatures. So you are seeing a big impact on human health in these regions.
So you've got to measure temperatures, certainly, for a start. So I'm assuming then that some of this equipment, quite a few of which I've not actually seen before, and couldn't quite tell what it is, although I'm suspecting that the spinning cups on some of them are measuring perhaps wind speed.
That is correct. Most of the equipment you can see here that's dotting about, we've got some rain gauges.
Right, let's just pop
monitoring
over.
Rainfall, so that gives us an indication of the amount and intensity of the rainfall we're getting. We've got quite a few because obviously rainfall does vary quite a lot spatially, so we do need quite a few to be able to have checks between them.
And you've got the rain gauges just like little small pedal bins with funnels, pedal bins with funnels.
They're tipping bucket rain gauges. So what happens is when the rain comes in, they've got almost like a bucket as such in there that's very small and has a certain amount of rainfall in there. Every time it's filled up, it tips. So for each tip, it kind of makes a mark, which is then recorded within the data set, and we can then work out how much rainfall is actually being collected.
And is that next to it? It looks like a long
temperature probes. We have a few on the grass, which are measuring grass temperature, and we've got a few on concrete that's just giving us the kind of artificial surface temperatures. We've also got temperature probes that
are these sort of yellow sticks in the grass.
They're all measuring temperature at different depths. So we can get an idea of how temperature varies with decreasing depth below the ground.
Now, this is just one weather station in one part of Birmingham. Yeah. We're talking about Britain's second largest city here. how are you measuring across the city itself in terms of so that you understand the differences in temperature and other effects across
this
the
site
city?
here is essentially measuring urban background conditions. It's not completely in the city centre, it's just slightly out in leafy Edgbaston, so we call this an urban background site. At Paradise Circus within the city centre, the Met Office have just opened up a truly urban weather station site, so that's bang in the middle of town, so that will give us some urban readings, but that's just opened up in the last 12 months or so. What's traditionally happened in terms of getting an idea of these urban heat islands is we've actually used the data from this site here and we've compared it to the Met Office rural station site, which is based at Coles Hill, which is just outside of the Birmingham conurbation. So what we've done is actually just kind of taken those pairs of data sets and actually looked at how they differ to get an indication of how temperatures vary. Obviously that's not good enough to be able to assess how weather and air temperatures vary across a region as big as Birmingham. We've got so many different land uses in the area. We need to get a better indication of how they actually do vary.
And how have you done that?
This is where HiTemp comes in. We're setting up the Birmingham Urban Climate Laboratory, which will be a very dense network of weather equipment across Birmingham. We think it should be the world's densest urban network once it's actually completed. So it is a big thing for the UK, let alone Birmingham. And what we'll do is we'll have 25 automatic weather stations, very similar to some of the equipment that you can see here. They will be located in primary electricity substations. The reason we've gone for electricity substations is that one of our partners is E.ON, specifically Western Power, part of E.ON, and they're actually interested in how urban heat and excess temperatures can actually have an impact on energy supplies. So in the future, with changing climates, obviously temperatures will increase. This could have an impact on energy supplies. We've got 130 or so going out into schools across the region. These are Wi-Fi battery powered, so all the data gets sent across the school Wi-Fi, but we are putting them in school sites so that they're secure, we can use their Wi-Fi to transmit the data, and also to get the school kids involved, because it's really nice to get kids at school actually involved in some real science. So all the data that's collected they'll have available to them to actually use in class.
This is quite an exciting stage you're at now. It's getting it underway.
It's just kind of taking off at the moment. We're starting to install the equipment. That's a big job in itself. I mean, it's a lot of effort to actually implement all these pieces of equipment across the region. Once we've got that set up, though, it shouldn't take too much to actually look after them, because all the data is coming in automatically to us every hour. All we need to do is process the data, quality check it, and then we can upload it onto a website that anyone can actually access if they want to have a look at what the temperatures and the weather is actually doing across the region.
And as you've already sort of highlighted, this will have quite an effect, or give you an insight into a whole range of procedures, be it energy usage, temperature, buildings, which areas perhaps are losing more heat than others, or are getting perhaps dangerously overheated in terms of health or pollution.
Well, we've mentioned about the health and the energy impacts of urban heat. Obviously that has an impact on the kind of transport infrastructure, so you get rails that can be buckling under excess heat, even tarmac can be melting on the roads. So we obviously need to know what areas of the city have a higher risk of these things occurring, and then we can actually kind of think about ways to mitigate and adapt to any kind of changes that are going to occur with climate change, particularly in urban areas.
Dr. Catherine Muller from the University of Birmingham, thank you very much. And you can see photos of the weather station here in Birmingham on our Facebook page. Back in time now to almost 50,000 years ago, and the final days of the Neanderthals and the rise of modern humans. New research published in the journal Science recently revealed the oldest known cave art in Europe, and it might not have been painted by humans. Richard Hollingham has been to Bristol to meet the archaeologist who led the study, Dr. Alistair Pike.
This is the closest the University of Bristol has, I think, to a prehistoric cave. I'm in a lecture theatre and we've projected across one wall an image from one of the caves being studied by Alistair Pike, an archaeologist here at the university. And the image is ghostly almost. There's a creature, maybe a bison or a buffalo, in the top left-hand corner. And then there are other rather indistinct, maybe handprints across the middle. Alistair, what are we looking at?
We're looking at the Panel of Hands. It's a part of a cave called El Castillo Cave in northern Spain, very close to Santander. And this part of the cave, maybe 41,000 years ago, was decorated by people putting their hands against the cave wall and then blowing or spitting pigment to create these negative hand images.
I mentioned it was ghostly, and that's because it's got a covering over the top.
Yes, water that's been dripping down from the ceiling has deposited a thin film of calcium carbonate, a bit like stalagmites and stalactites that you see in show caves, and that's obscured some of these images.
How old are these?
We know that some of the red discs, so next to the handprints there are some red dots, and one of those red dots is at least 40,800. But because we can see that they were made in the same technique, they don't overlay each other, we think actually the handprints were made at the same time.
What does that mean then? I mean, it sounds an awful long time ago, but that has particular significance.
Yes, well, first of all, it's at least 15,000 years older than we previously thought the art in this cave to be. But it dates from around the time when modern humans first arrived in Europe and the Neanderthals begin to disappear. But because we're dating these deposits on top of the art, we don't actually know how old the art is. All we know is it's older than 40,800, and therefore it might have been made by Neanderthals.
Would that be their first?
Absolutely, or certainly painting. This would be the first example of Neanderthal painting. So you can look at the fingers, the handprints of Neanderthals, if indeed this is the case. But we do know that Neanderthals, maybe 50,000 years ago, were making art-like objects in other parts of Spain. So we find things like shell beads to use for body adornment. We find shells that have traces of pigment in them that look like they might have been used as a sort of cosmetic even.
So once again, Neanderthals turn out to be a lot brighter, a lot more advanced, if I know archaeologists hate using the word advanced, but that than we perhaps thought.
Well, if this genuinely is Neanderthal art, and we haven't yet proved it beyond all doubt, because conceivably it could have been made by modern humans a matter of a few hundred years after they first arrived in northern Spain. But if it does turn out to be Neanderthal, then it's showing that Neanderthals have the cognitive abilities rather similar to modern humans. So we've narrowed the gap in the difference between them.
But even modern humans, when they started turning up in Europe, they didn't have a culture of art before that, is that right?
Well, that's a very interesting question because, in fact, in Africa, we do find art objects around 70 to 100,000 years ago, which include little bits of engraved red ochre minerals. We find beads and bead necklaces, and we find engraved ostrich eggshells. But the earliest paintings in Africa are only around 25 to 27,000 years ago.
So a lot more recent than the ones here, for instance.
Absolutely. So it looks like the tradition of painting caves started in Europe. And that's a really interesting question to ask. Why should it be that humans should start painting caves in Europe and not in Africa when they'd been making art objects in Africa for the previous 50,000 years? And we think we've got an idea about why this is, and that is actually the presence of Neanderthals. And we find just after humans arrive in Europe, we find the first examples of musical instruments, of figurative sculpture. We may have found the first example of painting. And the difference between Africa and Europe at this time was the presence of Neanderthals. So it might have been that in order to compete for resources with Neanderthals, modern humans had to organize themselves differently socially, and art may have been one of these innovations that allowed them to create a group identity and therefore compete with Neanderthals.
So if we look up at this image projected on the wall of the lecture theatre here, you've got these handprints and this shadowy image of a bison or something, and concealed by this calcium deposit over the top. How on earth do you go about finding out the age of this without damaging it?
Well, the key to actually being able to date these things is that calcium carbonate deposit that you mentioned. And we can use the radioactive decay of uranium, which decays to thorium, to work out when these things formed. And it's the measurement of the thorium to uranium ratio that tells us how much time has passed since the precipitation of the calcium carbonate. And since these formed on top of the paintings, we know they must have been older than the dates that we're measuring.
So actually, it's relatively straightforward thanks to the material that's obscuring them.
Absolutely. Some people might think it's a shame that you can't see all of the art, but it's thanks to that layer that we can actually obtain age information about the paintings.
Now, we talk of this as prehistory, but I suppose this really was the first history, particularly as people came back. It's a record, really, of humanity.
Oh, absolutely. And there's some studies that have actually looked at some of these symbols, and they find groups of them reoccurring in different caves all over Europe. So, in fact, we might be looking at a form of language here.
So really, this is the start of so much.
It's the beginning of the modern period for humans, if you like.
And What do you want to do next? I mean, where can you go from finding these? 'Cause this is just amazing stuff, and it's tantalising in a way that you think it might be Neanderthals, but you can't prove it.
Well, first of all, we've got to prove that it either is or isn't Neanderthal. So we're going to go back, in fact, to this very cave and take more samples. And if there's a very significant period that has elapsed between the painting done and some of these calcite things forming, we'll start to home in on the actual date of the paintings. But we find these kind of handprints and these red symbols all over Europe. And if they are Neanderthal, then we want to go and find them in other places to show that, in fact, this is a widespread phenomenon, not just something isolated in northern Spain.
Now, just looking at this image, okay, we're in a lecture theatre. This is pretty incredible. And because it's blown up on the wall here and you can see all this detail, what's it like for real?
It's much bigger than that. This isn't blown up, this is shrunk. These places are amazing. I mean, some of these walls are completely covered in art that span 20,000 years, but you don't see them immediately because you're walking on with a torch, and I guess if you were an early human, you'd be walking on with some small lamp. And so they appear and they disappear in the shadows. And the artists have used the shapes of the rock to actually create that effect. And sometimes we see the art appearing because the wall is effectively three-dimensional, and then the shadow covering it up again.
Has it given you a new appreciation of our ancestors?
It really is an amazing thing to sit there whilst you're taking a sample and realise that this is 40,000 years old. Yet that hand is very, very similar to mine, and I could put my hand next to it, spit some pigment on it, and create my own version of it there and then.
Archaeologist Alistair Pike from the University of Bristol, and you can see some pictures of the cave paintings on our Facebook page. Meanwhile, here with news from the natural world is science writer Tamra Jones from the Natural Environment Research Council, and it's started to rain now in the podcast that we started off about urban heat. How ironic. So we're sheltering under an umbrella by Catherine. Tamra, let's start with something that will take us out of this sort of wet, miserable weather, talking about the colour of Australian birds. And it's quite amazing about how the colour of their head is a clue to their personality.
Yeah, it's these Australian birds called Gouldian finches. They're really beautifully coloured birds, red, black, green, blue, etc. But some of them have got red heads, red feathers on their heads, and some of them have got black feathers on their heads. And researchers led by John Moores University and the Royal Veterinary College have found that the birds with red heads are much more aggressive than the birds with the black heads. But the birds with the black heads are bold and they're risk-taking, which is really weird.
Now, this seems very similar to what you sort of hear with humans in that apparently those who drive red cars are more likely to have an accident. Is this the same with other species as well?
I'm not sure it means that birds are more likely to have an accident. It does mean that red has definitely been associated with aggression in fish called cichlids, also in reptiles and primates, and like you say, just in us as well.
So how did they know then that their behaviour was bold or aggressive or risk-taking?
Well, they did a number of different experiments, and for the black-headed birds, they found that when they presented them with a kind of silhouette of a hawk, which is a natural predator of these birds, when they went back to eat, they actually went back much quicker than the red-headed birds. So they were much more, okay, that's a bit of a risky sort of situation to get into, but let's go back and see if I can still feed, and that's what they did.
Where next then for this research?
The next stage is really to figure out which birds are associating with which one. So are reds associated with red birds, or the blacks associated with blacks, and what does that mean? Where does that get them?
Where indeed. And another fascinating story next about carnivorous plants turning vegetarian.
These plants are sundew plants. They grow in rain-fed bogs in Sweden. And the thing is with these bogs, they're not very nutrient-rich. And the researchers had found that instead of getting their nitrogen from the insects, they're actually getting it from elsewhere.
So instead of chomping down on the equivalent of meat for them, which is your midges and your insects, where are they getting their nitrogen from?
It turns out that nitrogen is being deposited in the rain, so it's pollution from industry and farming, agriculture, that sort of thing. They're getting loads of nitrogen in the rain. They don't need to rely on the insects anymore.
So apart from changing then behaviour, this is also potentially being an indication of pollution if you discover that plants in a particular area are not getting their nitrogen from insects.
Absolutely, because they found that these plants in more polluted areas were relying much more on the nitrogen in the rainwater and didn't rely on the insects, and the ones in the less polluted areas weren't relying on the insects at all. In Britain it could be even worse because of course there are a lot more polluted areas than there are in beautiful Sweden, so they're actually going to look in Britain next and figure out whether or not it is applicable to Britain and whether or not it's the same situation.
And finally, milk drinking in the Sahara.
Yeah, a bunch of researchers from Bristol University have found that people who lived in northern Africa and the Sahara way back 7,000 years ago were processing milk. They weren't actually drinking milk, they found. They were actually processing milk into butter and yoghurt and cheese, which is pretty amazing. 7,000 years ago they were doing this.
So this is much earlier than was previously thought, because they've known that they were using cattle for meat, but not necessarily for dairy products.
I don't think it's necessarily that it was much earlier. It's more that it confirms what people have been thinking, because on the rock art around Libya and Algeria, actually, there are lots of pictures of people with cattle, and in very rare cases you can see the cattle with full udders. So there's lots of sort of circumstantial evidence that they were using cattle, but they weren't really sure what on earth they were using for.
Great. Well, we'll definitely look at that story in more detail then in a future edition of the podcast. Tamara Jones, thank you very much. And you can read about all of those stories on Planet Earth Online. Well, this has been the Planet Earth podcast for the Natural Environment Research Council from Birmingham. Don't forget to check out our Facebook page and Twitter feed. I'm Sue Nelson, standing in the rain and the wind. Thanks for listening.